So we're going to do a little bit of algebra. Don't feel lost. Don't worry, this won't be on test. By the way, I still see some earbuds, so let's go ahead and put those away. Put your cell phones away in your backpacks. So we're going to do a little bit of algebra. It may seem intense, but write this down, and we're going to plug some of this into the spreadsheet and let the spreadsheet do the math calculations for us, okay? So what I want to do is I'm curious. We can pull a lot of information from us just going outside. All right. So right now we do have one equation. We have this equation right here. This one right here that we did from the information. So basically, every time we pumped with a bike pump, we measured how far it would go. Some additional information. One of the things that I didn't really share with you guys yesterday is that I tried to make sure that I shot at about 45 degrees. So my angle of elevation, so just like that simulator you guys just did, I tried to shoot it at about 45 degrees. Okay. I was constantly holding the t-shirt launcher, and I'm going to keep saying yesterday, but we all know it was the day before yesterday, okay? And so there's a couple of things that there's some information that we can find from the data that we collected by just pumping up the launcher with a bike pump and then shooting it. There's two things that I'm really curious about, okay? Actually, there's three things, and I don't know how far we're going to dive into this, but the first thing that I'm curious about is the velocity, and I want to try to relate the velocity to the pump. How fast will that t-shirt come out of that cannon per pump? So what I've done is, if you notice, I have two equations that equal delta x. So if this, and this, we're going to do some pretty, I don't want to scare you and say it's intense algebra, it's just algebra. And we're going to try to solve the equation for velocity. Now, one other thing I should probably mention is that sine of 2 theta would be the same as sine of 90 degrees. And that's just 1. So let's write that down over here somewhere. Sine of 2 times 45 degrees is equal to sine of 90 degrees, which is just equal to 1. So I did that on purpose, so that way this just equals 1. And so that makes our life a little easier, okay? So what I'm going to do is I'm going to take, this ends up becoming v naught squared, and this is the velocity of the t-shirt as it comes out of the cannon, divided by g is equal to delta x, right? But also equal to delta x, which is the distance that the t-shirt travels, is 0.67 p minus 3.12. Okay? So I'll leave that up there for a second so you guys can kind of catch up to me mathematically. So what I want is an equation that when I multiply, in other words, I want to kind of be able to calculate what the velocity is per pump, right? I want to calculate what the velocity is per pump. And that helps with our simulation, right? So algebraically, what I need to do is I want to get v naught squared by itself. So I'm going to take this whole thing and multiply it by G, and then over here I'm going to multiply by G as well. That's a legal move, right? So these G's cancel, and on the right-hand side I get V naught squared is equal to, and I'll put the G in the front, G times 6.7, or 0.67, sorry, I said that wrong, minus 312, okay? And I'll slide that up so you can see it a little better. Well, we know that G is really just a number, right? Oh. And G is 9.8. So G is one of those things that we know that if you go down, it's negative 9.8. But we do it that way, but also there's the equation, and there's a separate equation where you make it negative. And then to complicate matters, we're going to have a square root. And so we're just going to leave it as 9.8 for today. All right. So the next step is I'm going to say 9.8 times this 6.7 times P minus 312. Now, to simplify things and make my life easier, I'm going to distribute that 9.8 through the parentheses. So I'm going to take my handy dandy calculator, and I'm going to say 9.8 times 0.67. So I get 6.566. So my first term is 6.5, we'll just say 57 because it's 66. So we'll round up. Normally you wouldn't do that, but we've got a lot of room for error. Okay. And then I take that same number and that 9.8, and then I multiply it by the 3.12, which is actually a negative 3.12, so I have negative 30.58. So this is minus 30.58. And then to get just the velocity, I'm going to take the square root of both sides. And so the velocity of that t-shirt coming out of the t-shirt launcher is approximately 6.57 P minus 30.58. Okay. Approximately. Now this, I should probably, and it doesn't really matter to you guys, but remember there was air resistance, the wind was blowing. So what we're saying is all these calculations is based on being outside and the wind kind of blowing towards the t-shirt, right? And when you just did the simulation, by the way, what did you notice about the simulation? Did it land in the same spot every time? No. It landed around a center though, right? It seemed to hit the target more times than it didn't. So you should have got like a normal distribution, right? Like there was a big heap in the middle, and then there were, as you got further away from the target, there were fewer and fewer spots where it didn't hit the target. Okay. So now that we have this equation, we have to plug that into our spreadsheet, which I got to find. Here it is. So what I want to do is on this spreadsheet, let's make another tab. So see this plus button down here? So we need to open up our Chromebooks. And there'll be this little button here. That'll add a tab. So if you click on that, it'll say Sheet 2. And what I want to do is I want to drag that over here past the chart. And you get a new thing. And so in this column, what I would like for us to type is the number of pumps. And then over here, we're going to calculate the velocity. And put INI for initial velocity. And we'll call this third sheet, double click on that, call it calculations. Or just call it velocity. Velocities. All right. So now here's an interesting dynamic. Yesterday we counted by 5. So we're going to say 5, and then what comes next? 10. And what comes after that? 15. Now I showed you this shortcut before, but if I select all 3 of these, once I've selected those, if I scroll way, way down here, it'll continue the pattern. And I want to go to 100, so we'll stop at 100. So if you select all 3 that you typed, and then it'll highlight it in blue, and then there'll be a little dot in the lower right-hand corner. Grab that dot and just drag it down. It'll count all the things. And so now I need to put that equation in there that we just came up with. I'm going to plug this equation in here. I'm going to say the square root of the number of pumps minus blah, 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 blah. Okay. Let me write this down on a piece of paper because I'm pretty sure I'll forget. All right, let's do it. So to get this value, what I'm going to do is I'm going to say equals. Then to type in square root, you say SQRT, and then you open parentheses. So SQRT, open parentheses, and then I type in 6.57 times, well, I'm going to get this number, the number of pumps from A2. Then we're going to say minus 30.58, close parentheses. Okay. So if I pump that thing theoretically, right, we don't know if that's going to generate enough force for it to pump completely out of the t-shirt launcher. But if it does, it should come out, and it's about 1.5 meters. Or no, this is the velocity in meters per second, yes. You just put 30.5? I don't understand what you're saying. 30.58. Mr. Adams is old. I can't hear very well. All right. So now, does everybody have this formula typed in? And so when you hit enter, it's going to say, do you want to autofill? Now, autofill will calculate the velocities for all of these. So I'm going to say yes by clicking the checkbox. Yes. You have it written down in your notebook, don't you? It's this equation. But the way that you type it in is you're going to see this formula up here. To do the square root symbol in here, you're going to say equals SQRT, open parentheses, and then instead of the letter P, we're going to pull the value for P from A2. And then when we autofill, notice that it changes it to A3. It'll pull the data from here, and then it'll pull the data from here. So it'll pull the data from the corresponding things. You're welcome. So, if you pump that thing 100 times, it'll come out with a velocity of 25 meters per second. That is really fast. And then we can approximate using our other equation how far it will go. So in this third one, we're going to say distance in meters. Okay, so down here, we're going to do the same thing. We're just going to say equals, and it was actually 0.66 times this value here minus 3.12. That's just the equation we got from our chart. And then we autofill that. I'll put the equation back up there. And so it says on average, if you pump it 50 times, it'll go 30 meters. Yes. Oh, okay. So there's two ways to do it. If it doesn't ask you to autofill, let's do this. If it doesn't ask you to autofill, you could see this little blue thing, the little dot here. You just drag it down to the end, and then it'll automatically autofill. We are almost done. We're going to convert this to feet, and then we're going to turn on the lights and set up our lab for when we meet next time. Okay, before I move forward, do you guys, is everybody on the same page as Mr. Adams? Everybody have this stuff listed? So last thing we're going to do is distance in feet. Maybe. Distance in feet. And so we're going to convert that to feet. So there's a couple of easy ways to do this. Now, we used to give kids books, and in the back of the book it would say that, but I'm just going to say meters to feet, and Google knows. So 1 meter equals 3.28 feet. So in our spreadsheet, we're going to say this value times 3.28. So 1 meter is a little bit longer than a yard. Okay. I'm going to hit enter. Now, if it doesn't give you that prompt to autofill, another way you can autofill is you select this and then just pull that dot down. And all it does is it puts it's just taking the value from this and multiplying it by 3.28. Okay. And then I've got some extra decimals here. I don't want those there, so I'm going to click on this to decrease the decimals. You guys should remember that from the other labs. Same thing over here. I'm going to decrease some of these decimals. It doesn't delete them. It doesn't round them. I mean, it rounds what you see on the screen. Notice none of these numbers are changing. It just rounds what you see here and makes all the calculations all the way out to the end. It just rounds what you see. It keeps track of all the values, actually. Okay? Now, if you want to do something for fun, you can actually click on A and hold Shift and highlight all the way to D. And now we'll make one more chart. And you come down here to Insert. Did I pass it? Oh, there it is. Chart. And it's recommending a column chart. I don't know. We could leave it like that. And then make that its own chart. Make that its own sheet. And just say calculations. So the blue line is the number of pumps. You can see what the velocity is. You can see what the distance in meters is and how that equates to feet. The more pumps you have, the greater the velocity. Okay. And then I'm going to, if you give me 2 seconds, I'm going to have you guys submit your sheet. So give me a second here. I'm going to put it to where you could submit this. Remember to use Google LTI when you submit a Google spreadsheet for homework. Everybody has to submit their own individual thing. Now, I know that I see there's a couple people absent today, so make sure you share this spreadsheet with the members of your group. They're going to have to remember to turn it in. So this is actually going to be, hold on a sec. I got to move it to the bottom of the, so it's going to be in the T-shirt launcher module. Yeah, under T-shirt launcher. So it'll be right after 12. So it should be published. So go ahead and submit those right now. Refresh your screens. And that's it.